Hi, my name is Martin Gadsby of Optimal. Today I'd like to take you through the technical aspects of deploying a PAT project. Well, first of all, there's a cultural change. You have to change the culture within your business because the implementation of QBD and PAT is a mindset change, but it is the way to go. Then you have to build the PAT teams. The PAT teams might well comprise of many of the folk within your business, but also you can bring in third parties such as Optimal, such as other consultants to help you on your PAT journey. They might help you on your first or second deployment, and then you learn all the skills and you can bring all the technicalities in-house. Then you need technologies. The selection of instrumentation is going to be very specific. It's going to be dependent on your product type and on the CQAs, the critical quality attributes you're trying to measure. The fact you've selected the correct instrument and put it into your process does not mean to say you're going to get good results. You have to have the instrument in the correct position to get sampling that is representative of your process. This is critically important. We strongly recommend that you work with an instrument vendor to select the optimum instrument for the CQA and product in question. You need to select your software products. You need DOE software, design of experiments, you need MVA software, and you need a PAT knowledge manager such as synTQ. So you select these products and put them into your IT infrastructure. Your knowledge manager is the center really. It is coordinating all the disparate systems. So with your infrastructure in place, you can start the process. The first stage is you have to change the data that the instrumentation is giving you into information. Now you do this by using MVA software packages because the MVA software packages can find the latent variables within your data to change that data into information. We use DOE software to give us the maximum amount of data from the minimum number of experiments because we want to minimize the number of experiments. Experiments cost time, they cost raw materials, so you want the minimum number of experiments. Using your knowledge manager, you run your process and you configure your instruments and you collect data from all your instruments. And when you're at a stable sampling point as dictated by your DOE software, you gather all the spectral and univariate data, and you also take a physical sample from your process at the strategic point that is representative of the process. So using your PAT Knowledge Manager, you select data sets and export those to your MVA package. A chemometrician uses the MVA package to build the models, and what he's doing is he's converting all the data inputs, loading in the results from your laboratory and converting this into a statistical model that will produce quality predictions based on the data inputs. You then bring the model back into your PAT Knowledge Manager, and then you can validate your model by using the data sets that you haven't used for model building. Now we can predict product quality to a suitable standard in real time. We can now run more experiments whereby we alter what we have deemed to be critical process parameters and see how the CQAs vary with changing CPPs. From this, the process scientists can develop what we call the mechanistic understanding. They can understand how the process affects the product quality in real time. And once they have this understanding, then they're able to develop control algorithms to control the process based on product quality. So now we have a situation where we are measuring product quality in real time and we understand the process. So as I move from the laboratory to pilot plant to full manufacturing, the scale-up time becomes a lot less. And indeed, if we're looking at a continuous process, which PAT enables, then the scale-up time from pilot plant to production may be zero because the equipment you're using for pilot plant may be the same as in the manufacturing environment. So now we're running the process, we're getting a real-time control based on quality, so we've already had benefits in terms of quality, cost and manufacturing and scale-up time. But PAT embraces continuous improvement. When you're running in production, you go from 50 batches to 100 batches to 1,000 batches, you become much more data rich. Using your knowledge manager, you can select key data points and add those retrospectively back into your model, and once you validate your model, you can use the new model in production, which will further improve the quality, cost and manufacturing time benefits. If you have any questions at all, then please do phone Optimal and we'd be delighted to help you.